Consider a beaker containing a liquid of density rho. Let this be the surface of the liquid. Let rho be the density of the liquid. Density of liquid. Let there be a cylinder, a body in the shape of cylinder, immersed in the liquid like this. Let sigma be the density of the body. Density of the body. Let A be its cross-sectional area. A equal to area of cross-section. Area of cross-section of the body. And let H be its height. H be its height. Now, let the top surface of the body is at a depth of h1 and let the bottom surface be at a depth of h2. H2. Now we have the different forces acting on the body, not the different forces. The force acting on the top surface of the body is F1 and that at the bottom surface is F2. But we have force is equal to, force is always F1 is equal to pressure at the top surface into area. We already know the cross-sectional area is A. So F1 will be pressure into area. So F1 equal to, but you know pressure at a depth P is equal to, we have H rho G. So P1 is equal to H1 rho G times A. Similarly, the force acting at the bottom of the cylindrical surface will be F2. That 2 is equal to the pressure into area. Pressure at the bottom of bottom surface into area. Therefore, F2 is equal to H2 rho G into A. That is equation number 2. And you know H2 is always greater than H1. Since the depth H1 is greater than, since H2 is greater than H1, we have the pressure at the bottom greater than the pressure at the top. Obviously, the force F2 will be greater than F1. So there is a resultant force or you can call that upthrust, or this upthrust is called buoyant force. Let's call that as F. Since F2 is greater than F1, we have resultant force equal to F2 minus F1, and the direction of, since the direction of F2 is in the upward direction, the resultant upthrust or the buoyant force in the upward direction. Clear? Now if you substitute the values of F2 and F1 here, we get H2 rho Ga minus H1 rho Ga. You can take that rho Ga outside. Therefore, F is equal to, if you take rho Ga outside, rho Ga H2 minus H1. So the resultant upthrust F is equal to rho Ga, but you know H2 minus H1 is the height of the body, or H. You can write this as AH rho G. So this is the resultant upthrust or the buoyant force acting on the body. Now let us interrogate the different terms in the equation of force. First, you know, the term A into H which means base area of the cylinder into height, that is this base area into height gives the volume of the body. So F is equal to, you can write AH as volume V rho G. But if you immerse any body in a fluid, this equal volume of fluid will be displaced by this body, which means the volume of this body is same as the volume of the liquid displaced. Whatever you immersed in a liquid, the volume equal to the volume of the body is displaced by that body. Clear? So the volume is this, and the displaced density means the density of the fluid displaced, since the density of the liquid inside the beaker is 4. Volume into density gives the mass of the liquid displaced. So F is equal to, you can call that let's call that as m dash G. So m dash means the mass of the liquid displaced and G means the gravity. So this will give the weight of the liquid. Mass times gravity is weight of the liquid displaced. Display. So this principle is called Archimedes principle. You can say that this F, we already took that as F is the buoyant force. Buoyant force is equal to weight of the liquid displaced by the body. So when a body is partially or completely immersed in a liquid, that body displaces certain amount of liquid equal to, and the weight of that liquid displaced is equal to the buoyant force acting on the body. Or you can say that buoyant force equal to weight of the liquid displaced by the body. And this principle is called Archimedes principle. This principle is called Archimedes principle. Clear? Archimedes principle.